Hello, prospective game developers. This is Akir. I recently went over the first major UI pass after doing multiplayer input on our game, Misc, and I realized just how difficult doing multiplayer, let alone multiplayer UI with cursors, could actually be. Therefore, I decided to do a miniature series about getting both basic multiplayer working as well as multiplayer UI in Unity. During this series, I may not end up doing things the typical Unity way, as I am more concerned about getting things running with whatever resources I can muster. I will also typically be doing as much possible in code, and may at times even drop down to lower level materials in order to show what is actually going on at any given time. My end goal is to show full project setup all the way to both local and network multiplayer action. So, let's just get started. First of all, to start our setup, we'll of course need Unity itself. In this step, I'll be going over all the things we'll be using in this project as well, but if you're already completely set up, feel free to skip this part. My current version of Unity is 5.6.3 F1, but the current version of Unity at this time is in the 2017 range. Feel free to grab the latest version, but if you want an older version, go to getunity/download/archive as shown here. Follow the directions during the Unity install to completion here. You may want to also select additional modules like WebGL or Android. I will most likely be showing off at the very least some Android and WebGL basics during this series, so please grab them if you want to follow along there. While Unity is downloading and installing, let's take a look at what else we're going to need. In making our game assets, including a lot of UI, we will at the very least need an art program or two. We have several options here, including Paint.net, Aseprite, GraphicsScale, GIMP, Photoshop, and more. I will be using GIMP as it is free and I am familiar with it, but you can choose what you like. I would also recommend a 3D art tool like 3ds Max, Maya, or Blender for making simple models. With the little that I will do, I will be using Blender and will go over the basics of model creation and the asset import pipeline. A full Blender tutorial or a 3D art tutorial, however, are both beyond the scope of this video though, so you may need to look that up on your own. In addition to art, I will be using some very basic sound creation software called VFXR to create some very simple sound effects. For music, I may do some very simple MIDI creation, but more than likely will simply search for free, usable game music, as actual music creation is also far beyond the scope of this video. With art programs and the auto taken care of, we will also need a good way to document our development. You can use some sort of office program if you like, but I will be using Notepad++ here. I will be using some basic version control software and be keeping several sets of backups. You typically always want at least 3 backups, with at least one of them off-site. Multiple backups are always necessary as many things can happen, whether it's a fire, your laptop being stolen, or other such catastrophe. For version control, you can use something like SVN or Git, and I'll be using Git here. You can create an online repo for your project on sites like Bitbucket or GitHub as well. In addition, services like Dropbox or Google Drive may be useful for backups or group collaboration as well. From here, let's go ahead and set up our folder and initialize Git for our project. When you have Git installed, you will see right-click context menus on certain folders that will allow you easy access to Git for repository management. Here, I'm going to use the simple git GUI to create a new repository in this folder. When this is done, you may not see anything in the folder, but the repository is there, it's just hidden. Now, let's open up Unity and start a new project. From here, simply click on New, or if you haven't logged in and created a Unity account, do that first. I'm going to call my project Multiplayer from Nothing and save it in the folder that I set up. Okay, what we want to do right now is simple familiarization with the Unity UI. Over here, we have what's called the scene view. This is a look at what exists in your actual gameplay field, which, at the start, isn't much, if anything. You can move this view around by holding down the middle mouse button and dragging, look around by holding down the right mouse button and dragging, select objects by left-click, or left-click and drag to select multiple objects, change the view from 3D to 2D, select various rendering options for debug purposes, and a few other things that I won't be getting into at this point. Below this window, we see the game window. This window is actually a view of the scene rendered from a camera in our scene. Without this camera, we would see nothing, which is I will show in a moment. Also in this section, we see a few other options like maximize on play, mute audio, stats, and a few others. But our most important other thing down here is the resolution selection. One of the most important things when we do start a new project is figuring out what resolution we'll be wanting natively. This holds doubly true if you are targeting smartphones or tablets, and you may need to do a little bit of research into how exactly to best set up your scene then. But for our purposes, I am just going to leave it as 16 by 9 for now. Over in this section, we see the project folder. This shows the files currently loaded in our project and is our main asset organization point. While we are down here, let's go ahead and right-click, create folder, and call it _ scenes. From there, we need to go to the File menu in the top, select Save Scene As, and save it as Scenes as main. The very basics of Unity requires scene creation and saving of said scenes, so it's good to get this part out of the way. After that comes the linked sections where most of the time in Unity Editor will be spent: the hierarchy and the inspector windows. Whenever you click on an element in the hierarchy window, you can see information about that object in the inspector window. For example, here is our main camera. As you see, if you change the values on the camera, you can see the game view change. If you turn off the object up here, you can see that the game view reports no cameras. There are also other things attached to the main camera, like this audio listener object. Unity requires exactly one of these in any given scene, as these components are what listen to audio in the scene for things like sounds with 3D fall-off effects. I will go over more of the camera stuff later, but for now, let's move to game object creation. Over in the hierarchy window, you can create a new empty game object by right-clicking and selecting Create Empty. If you right-click on an object when you do this, you create an empty game object as a child of that object. I say empty, but it's not quite. Over in the inspector, we see a transform component. Every game object has a transform component that gives a position and placement in the hierarchy. You can see more about these components in the Unity reference docs, where we're going to be seeing a lot of these docs, as nearly everything you need to know about these components can be found here. Let's go back to the Unity window and take a closer look at the game object we just made. Under the game object, if you click Add Component, you can see a list of things we can possibly add. Right now, we are going to add a mesh filter and a mesh renderer. The mesh filter is what contains the model data of an object mesh, and the renderer determines how it is rendered. Right now, we have no model data, so let's go to the mesh filter and add one. This can be done by clicking on the knob to the right and selecting one of these defaults that appear in our new Select Mesh window. Let's add a cube. Now, we can see a cube in our game and scene windows, but it appears as purple because we don't have a material added to the mesh renderer, as you can see down here in Materials. You can also use the knob here to select a default material for our cube. Let's select the aptly named default material. Now you can see that the look of the cube changed to white. Overall, there's not much that we can do with the default material though, as you can see in the inspector window. When we open the information on default material, everything is grayed out. We can, however, create a new material and add one we can do something with. Let's do that now. Back in the project window, let's add a new folder called Materials. Then, inside that folder, let's right-click, Create, New Material. Let's call this material Custom Material. Now, over in the inspector, you can see a lot of modifiable values. Change these around if you like. The preview window can give you an idea of what your material is going to look like, but for now, let's just change the color. Now, if we go back to our new cube and press the knob on Materials again, we can see our new material, the list of materials to add. We can also simply click and drag from the project window and place our new material in material slot, like so. Notice though, if you click on the material, instead of dragging it, the inspector will change to that object instead. You can lock the inspector over here by pressing the lock button, or by right-clicking the inspector window and selecting Lock. While this pop-up window is open, notice the other options here. The Add Tab option is useful if you wish to change the configuration of your windows, as you can have an additional view. The other most notable thing about the inspector window, though, is the Debug setting. With this setting on, you can see a lot more, very different information about the object you have selected. Most of this won't be immediately useful to you, however, but if you're ever wondering why you may be seeing odd things in your inspector window, click to make sure the debug mode isn't selected. Anyway, back to our cube. Right now, our cube is simply there as a decoration. If we go up here and press play, we see that nothing happens. Let's add another component, a rigid body. Let's also make sure our cube is centered to our game view by going to the gear on the right and selecting Reset. Now, when we press play, we see the cube fall down. This is because our rigid body component has gravity, which we can see over here. If we uncheck this checkbox and press play again, see gravity no longer applies. Let's turn back on gravity and then create something for our cube to interact with. Instead of creating an empty game object, this time I'm going to right-click and create a pre-made cube with 3D Object, Cube. Notice in the inspector that the pre-made cube is almost like our own cube, except it also has a box collider component and is missing the rigid body we added to the other one. Collider components are what Unity calls into to actually check for object collisions. Using the inspector, let's move our new cube under our old cube. You can either do this manually in the inspector, by using the move functionality in the scene view. Or, if you want something quick, you can go to the transform on our cube, go to the gear, select Copy Component, go to the other cube, to the gear, and select Paste Component Values. Then, you can trivially move it under our old cube. Now, let's press play to see what happens. As you see, our cube is still falling, but falls right through our cube that supposedly has collision now. That's because we need to add collision of our own to our cube in order for the object to interact. From our cube, go to Add Component, Box Collider, and select. Now we can see the Box Collider component active on our custom cube. If you change the values of center and size, you can change information about the Box Collider. This may be useful if you're using a custom model mesh as well, or if your collider otherwise does not match the visual of your game object. You can also see a slot for material on this Box Collider. This is not the same kind of material as what is on the mesh render, but is another type of material called a physics material. I will go over this more later, but for now, let's just press play again to see what happens. As you can see, the cube now stops instead of continuing to the other cube. There is, however, one more value on the Box Collider, the isTrigger option. If we press this and press play, we notice once again that the cube falls through the other cube. Triggers themselves are useful when you want something to tell another game object, hey, you just hit me, without actually using the Unity physics system and moving the other object around. Now, let's go ahead and create a custom physics material and see if we can make our cube bounce a bit. Go to Assets folder, right-click, create new folder called Physics Materials, and then inside it, right-click, create new physics material. Let's call our new material Cube Bounce. Over here, we can see friction and bounciness values. Let's set the bounciness value to 1 and see what happens. When we go back to our cube, drag the component over to Material slot, and press play. Oops, we forgot to take off isTrigger. When the cube contacts the other cube now, you can see it bounce a little bit. Let's go back and edit our physics material a bit to change the bounce value to maximum and see what happens. Now our cube is basically acting like a trampoline. Watch the cube bounce higher and higher until eventually it will bounce off. If we go back now and set the bounce value to minimum or multiply, however, you will notice that the cube does not bounce at all, it simply stops. That's because, effectively, the other cube physics material has a value of 0 since we haven't attached our custom material to it, and either a minimum or multiplication with 0 is simply 0. By changing bounce values as well as friction values, we can change how our object interacts in our game with the Unity physics system, so it's important to remember this for later. There are also other colliders we can assign to our cubes, which may give different results, especially on objects that aren't centered one above one another. Feel free to experiment further with other colliders and physics materials to see what happens. Now, let's go ahead and start with some UI. Over in the hierarchy, right-click and add UI text element. As you can see, a few things got created when you do this. Before we go further, make sure you can see your text on the screen. You can adjust back to 2D view and look at exactly where your text appears on the screen as well, and move the text element until it's inside, or simply reset its position to 0x, 0y for now. Now, let's look at the canvas itself. The canvas is what holds all of the UI components. Here we can see several options. The render mode on the canvas chooses just where and how the canvas renders. On overlay mode, the canvas renders independent of any of our scene cameras. This is the default mode and most useful for UI in general. The screen space camera mode attaches the canvas to a camera and displays its object in relation to the camera. This can include being behind world objects, however, so be careful using this. The world space option actually displays the canvas material as if it were a part of the 3D world. So if you move your camera around, you can actually see your UI move as well. You might not be able to see it now, but the text is inside the UI world. Let's set the camera back to overlay mode and move down to canvas scalar. The default setting here is constant pixel size, which means that any of your UI will attempt to draw the same amount of pixels regardless of the resolution. This also means that if you have a wide range of supported resolutions, if you aren't careful, your UI could become easily unviewable. The constant physical size, on the other hand, attempts to make your UI the same physical size on every screen, 1 inch per inch, etc. For now, let's select Scale with Screen Size and leave the default options in. Let's go back to our text object now. Let's move our text object to the top left of the screen here. You can move it with the values on the rect transform, which is a special type of transform component for UI. You can also change its anchor position by clicking on the grid box to the left, holding down the Alt key, and selecting the top left option to move it and set its anchor at the same time. Back in our scene view in 2D mode, with the text selected, we can see the bounds of the text element in the UI. If you adjust the bounds, you can see that the text can become invisible if we shrink it too much. This is because of the options over here under Paragraph in the text component. Wrap causes the text to fill down when the text box is too small, while Truncate causes any text that goes outside the bounds of the rect transform to disappear. You can also set the overflow mode to overflow, which means exactly that. The text will no longer wrap or truncate in the direction it's selected. You can also select Best Fit in order to set the text automatically to fit the window size. Up here, there are several font options that you can change as well, including the font itself. If you want to change its font, download a new font and save it in your Unity project and add it like the materials that we added before on the font slot. One notable thing about text is that your font may end up blurry at certain sizes and uses. In this case, what you want to do is increase your font size and then downscale the font size up in the rect transform. Depending on the UI that you do, you may end up having to do this eventually. On the next episode, we will go over scripting in C# and how to actually change some of these values in our game object programmatically. For now, let's go ahead and save our scene in the File menu. And then let's go back to our Get window. If you have closed this window, you could reopen it in the same folder you created it in by right-clicking and selecting Get GUI. Let's go ahead and hit Rescan. Once we hit Rescan, we can see all the changes to our files. These are all the files that we added. To get them ready to save in our Git system, press Stage Changed to add in the commit. You may get some warnings at this stage. This is because Unity is still open and has temporary files. If so, just close Unity and hit Rescan. Then try Stage Changed once more. Later, we will go over ways to avoid annoying warnings, certain classes of files, some other Git GUI systems, and also the Git Bash console. Once all of our files are staged, let's write in our initial commit message. This can be whatever you like, but it's best to be descriptive. Once you are done here, press Commit to save the commit to your local Git repo. If you have an online repo set up, you can use the push option as well to upload the files there. Git itself can be quite complicated, so I suggest further reading and a lot of practice to decrease the amount of time you need to mess with Git itself on each commit, and to also ensure the integrity of your Git repo. I would also suggest reading some more of the Unity docs, as well as adding other game objects in your scene to further familiarize yourself with the Unity workflow. That's it for now. Until next time, stay coding.